Hello friends, welcome to Ignited. Fluid mechanics or mechanics of fluid is one of the core subjects of both mechanical and civil engineering students and graduates. It is necessary to have a very thorough knowledge in this subject to crack PSC, UPSC and even GATE examinations. Today we are starting a series of classes on this subject. These classes will be very precise and will be beneficial to do a quick revision. Each video will be of 10 to 15 minutes duration. In this video, we are dealing the topic fluid properties. To begin with, the first property is density or mass density. It is denoted by rho. Its definition is given in the first sentence. It is the mass per unit volume of a liquid. Its equation is rho equal to m by v, where m is the mass and v is the volume of the liquid. Since the equation is mass by volume, its unit is kilogram per meter cube. Here we are given with an example. For water, rho equal to 1000 kilogram per meter cube. The second property is weight density or specific weight. It is denoted by small letter w. It is the weight per unit volume of a liquid. Its equation is given in the second line and it is small letter w equal to mg by v, where mg is the weight and v is the volume. Since m by v is rho, this equation can be rearranged as w equal to rho into g. From this equation, we can say that once we know the density of a liquid, we can find the specific weight by multiplying the density value with g. For example, we know that for water, the density is 1000 kg per meter cube. So its specific weight W equal to 9.81 into 1000 Newton per meter cube, and it is given in the fourth line. Its unit is Newton per meter cube. The third property is specific volume. It is denoted by small letter v. It is defined as the volume per unit mass of the fluid. Its equation is given in the third line, that is specific volume small letter v equal to capital V divided by m, where capital letter V is the volume and m is the mass of the fluid. We know that mass by volume, that is m by v, is density rho, hence v by m can be written as 1 by rho, and it is given in the third line that small letter v equal to capital V divided by m, that is equal to 1 by rho. From this, we can say that specific volume is the reciprocal of density. Its unit will be meter cube per kilogram. The fourth property is specific gravity, and it is denoted by capital letter S. It is the ratio of specific weight of a fluid to the specific weight of a standard fluid. Standard fluid can be air in case of gases and water in case of liquids. Specific gravity has no units. Example, for a mercury, the specific gravity is 13.6. The fifth property is viscosity. It is denoted by the letter mu. It is defined as the property of a liquid by virtue of which it offers resistance to the movement of one layer of liquid over another adjacent layer. We are all familiar with this definition. Viscosity is nothing but resistance offered by the liquid itself to the movement of one layer of the liquid over another layer. Viscosity is also known as dynamic viscosity or absolute viscosity. This particular point is very important. Viscosity mu is also known as dynamic viscosity or absolute viscosity. Both its SI and CGS units are very important. SI unit is Newton second per meter square or Pascal second. CGS unit is Dym second per meter square or poise. The conversion equation is 1 poise equal to 0.1 Pascal second. It is also very important. The sixth property is kinematic viscosity. It is denoted by nu. It is defined as the ratio of dynamic viscosity to the density of the liquid. That is nu equal to mu by rho, where mu is the dynamic or absolute viscosity and rho is the density. Here also Both SI and CGS units are very important. The SI unit is meter square per second and CGS unit is centimeter square per second or stoke. The next topic is effect of temperature on viscosity. In case of liquids, viscosity decreases with increase in temperature because intermolecular cohesion decreases. But in case of gases, viscosity increases with increase in temperature because intermolecular cohesion increases. The next property, that is seventh one, is surface tension. The tension of the surface film of a liquid caused by attraction of particles in the surface layer by the bulk of the liquid is known as surface tension. Its unit is Newton per meter. Here we are given with a table in which different equations of surface tension are given. In case of bubble, the surface tension equation is 4 sigma by d. In case of droplet, it is 8 sigma by d. In case of jet, it is 2 sigma by d. The next property is capillarity or meniscus effect. The rise or fall of a liquid surface with respect to general liquid surface in a narrow tube is called capillarity. Both capillarity rise and capillarity fall are shown in the figure. Water is showing capillarity rise and mercury is showing capillarity fall. In case of capillarity rise, adhesive force dominates. And in case of capillarity fall, cohesive forces dominates. Both capillarity rise and capillarity fall having same equation, that is H equal to 4 sigma cos theta divided by WD, where sigma is the surface tension, theta is the angle of contact, W is the specific weight or weight density, D is the diameter of the capillarity tube. For water, theta equal to 0 degree and for mercury, theta equal to 128 degree. The next property is compressibility and it is represented by beta. Compressibility is a measure of relative volume change of a fluid or solid as a response to a pressure change. It is the reciprocal of bulk modulus of elasticity. Its equation is beta equal to relative change in volume divided by change in pressure, that is equal to minus of change in volume divided by original volume divided by change in pressure. The negative sign indicates that volume decreases as pressure increases. This is the end of this class. Thank you.